Okay. Uh, Very good afternoon to all my dear future chartered accountants. I hope my voice is audible and the PPT is very clear. I hope my voice is audible. The PPT is clear. Yes. Good. Amazing. So how are you people? How things going on? How is going concern? Going concern is there or going concern is going? If concern is there, going concern is there. Okay. Let us wait for just a couple of seconds. Okay, good. So we have done few chapters after the basics. Before we go to the new chapter, let me just quickly give you the answer keys for the basic ones and the statistical description of data. We'll discuss the any issues you have, then we'll go further. Okay, so these are all the homework answer keys. You can just check it out. This is basics. On the basics, this is the homework keys on the basics. So this is the basics. If you have done, please compare it quickly. Okay, then th and 12th, that is 12 into 560. Then 5 into 12, that is also 60. Then if you divide 6 among 2 people, you get 3 each. Then 14 to 21. These are the numbers 14 to 21. Okay, next. 22 to 37. 22 to 37. Okay, next. 38 to 50. Thirty-eight to 50. Okay, next 51 to 55. 51 to 55. Okay, 56 to 58. 56 to 58. Previous one. Okay, next. 56 to 58. You want 58th one? Price of a apple was 150 per kg, and orange 50 per kg, and grape 25 per kg. You bought 20 kg of apple, 50 kg of orange, 12 kg of rice. You have to just have to multiply 150 into 20, 50 into 50, and 25 kg into 12, and add all of them. Multiply and add 150 into 50, 25 into 12, 50 into 150 into 50, 50 into 12, sorry, 50 into 50, and sorry, what is the number? 150 per kg into 20, 150 into 20, not this one, last one, 58. Okay, 58th one you want. Okay, suppose 58th. Okay, suppose 7 monkeys take 7 minutes to eat 7 bananas. How many minutes would it take 2 monkeys to eat 2 bananas? Okay, 7 monkey is taking 7 minutes to eat 7 bananas. So 1 monkey is eating how many bananas? 1 monkey is eating how many bananas? 7 monkey each will take 7 bananas. So each monkey is taking 1 monkey is eating 1 banana, and how long it is taking? For 1 banana, it is taking 7 minutes. Correct? 1 monkey is taking 7 minutes. Now, if 2 monkeys eat 2 banana, means what? They eat one only, no? Now also they eat one banana only, and 1 banana will still take 7 minutes each. But it is 2 monkeys eating 2 banana, meaning they are eating 1 banana at a time, and 1 banana will take 7 minutes. So previously also 7 minutes, now also 7 minutes. Hope you got that one. Actually, this was 61st. No, I think 61st. This is not. This was 61st, right? This one, not 58. This was 61st, I think, right? 61st. Okay, the question number was slightly misaligned. This was 61st. Okay, then from 62 onwards. Okay, 62 onwards. Yes. These are the answer you get. 62, various LCMs. Yeah, it's for 2 bananas, but each monkey is eating 1 banana only. No, 1 monkey is eating 1 banana, 1 more monkey is eating 1 more banana. That's how it becoming 2. But each monkey will take 7 minutes only. For one banana, they'll take 7 minutes. Okay. This is 62. $63. 63 to 67. 63 to 67. Then 68 to 74. 68 to 74. Any set of numbers will have just one LCM because least common multiple. No, the least one can only be 1. After that, many multiples can come, but least common multiple is only 1. Least is always 1. Least common multiple, lowest can only be 1 number only. Okay, next 75, 76, 77, 78. 75th one, 76th one, 77th one, 78th one. No, for M and N we have only one answer. We don't have two answers. We got only one answer. No, 4,34,400, 1,42,500. We got one answer only. We have not got two answers. Only one answer. All of these questions are there in PDF. Definitely, yes, it is there. If you open it, you'll be able to see. Decimal value is also fine. These are just for practice. These are not exam questions, just for practice. Okay, no problem. So 79 to 81. 71 to 81. Then 82 to 90. 82 to 90. You can have different form of simplification. These are all just for you to verify overall. Just for practice. These are not exam questions. So don't worry about the final number to be accurate. As long as you're able to get the process right, sufficient. Okay. This is till 90th. Then 91 onwards, 91 to 95. Okay, moving on. 96 to 99. 96 to 99. Okay, then 100th one, the table values, hundreds. Okay, next 101 to 107, 101 to 107, next 108 to 119, 108 to 119, 115 you have different question. Okay, let me see. 118. No, it is same only. It has gone to the next page, that's all. 118 is same only, it has gone to the next page. Same question only. Okay, next. Okay, so 120 to 122, 120 to 122, okay, the 123 onwards, 123 to 131, 123 to 131, okay, next. 132 to 136, 132 to 136, 137 to 143, 144 onwards, want 138. 138, just have to multiply. You do a into a, then you get a square, then you do a into a again, a cube. So you should just multiply, open the brackets and multiply. So first you do a into a, you get a square. Then a into b, you get ab. Like that you complete. Then you multiply this by a plus b. Again first into first, a into a square becomes a cube. A into ab becomes a square b. Like that you have to open the brackets. Keep opening the, first you open the brackets, a plus b into a plus b, then you bring one more a plus b plus c also. Keep opening the brackets. Okay, 144 onwards. 144 onwards. Okay, 150 onwards. Simultaneous equations, 150 onwards. Then 157 onwards. Okay, 161 onwards. Not able to hear voice properly. Actually, I'm not speaking much, so you may not be able to hear voice, but it may be because of your internet issues. Maybe that is the reason. Okay, next. 170 onwards. 170 onwards. 173 onwards. 173 onwards. Next, 179 onwards. 179 onwards. Okay. Okay, that's all I think. That was the basics. Let me also give you next. Okay. This is the set of answer keys for homework problem questions on statistical description of data. You can mark it. I'm getting one question. Is line graph and histogram are same? Definitely not. Line graph is line, histograms are bars. So line graph and histograms are different. What is the component bar graph? Subdivided and divided or percentage? So in the graph, you will divide into, like, out of total 100% in the graph, you will see filled, like sales of a company is 100 crores, 30 crore is net profit. So that is what is sub graph, divided graph. So you have one graph, sales of a company 50 crores, in that you say 5 crores net profit. So when there's a graph inside a graph, that's what you call it as sudden whatever it is, percentage bar. Hidden trend, when you look at the line diagram, you see a trend being following. You can see the numbers are increasing or numbers are decreasing. That is called as hidden trend. Actually, the trend, hidden trend, both are same. There is nothing called as hidden trend. Trend is also called as hidden trend. You can identify in the line graph or in the bar diagram. In the graph, when the numbers are increasing, like your marks card, like a batsman scores, profit of a company, when it is growing or coming down, the trend you can analyze in the graph. It's possible. You do not get the 54th sum. 54 you mean in this chapter? This 54th one? Okay, I'll discuss that. Annual income and marks of a student. We'll discuss. Tell me the questions as and when we discuss, we'll just discuss it. One is 54th. Okay. 54th we'll discuss. Please tell me the question number. We'll discuss those question numbers. So one is 54. Then we are discussing the homework keys. Let's stick to the homework ones. Tell me this in this list, which one? 31, 39, 40. Okay, let me just mark it. I'll discuss those. In homework problem 5th and 6th. Okay. $25, $49. Okay. $90th. $48, $78. $59. I hope you're trying and asking, not just a random numbers. Don't worry, I'll discuss, not an issue. 41. 60, 61, 70. You can't ask me everything, okay? 73, 74, 79. Please ask only when there is doubts. Otherwise, it's redoing everything. Abscissa, just x-axis, y-axis, we call it as abscissa, nothing else. Okay, there's a student called as Olive. Make sure it's registered, or if you're logging in some other's mobile or something, because if I remove it, then if I have to join, I cannot do it. I have to start a fresh meeting. That will take unnecessary 5-10 minutes. Okay, 43. Okay, I hope I've got the list of questions. Let me go for it. You want fifth and sixth. Annual income of a person. Actually, it can be either discrete or continuous variable. I'm just going away with what our institute solution has given. So I'm going with discrete variable. In a way, you can argue that it can be continuous also, but annual income of a person, usually you will know that your income is so much. A person's salary is known. So that's why we say it's a discrete variable. So it's an absolute number. Marks of a student is definitely continuous variable, definitely discrete variable, because marks of a student, you always know specific marks, how much you got. You never tell in a range. You can tell, but most appropriate is this definitely discrete variable. Marks of a student is more of a discrete variable. So 5th and 6th is done. 24th and 25th. Age is not a discrete. Age is continuous. Age is continuous because it keeps changing. No, every second it changes. Annual income can increase, it can decrease. We are not telling that, but when you express an annual income, it's always a particular number. That's why it is discrete variable. Bell-shaped, J-shaped, U-shaped, or frequency curve. That, like I told you, no, like right-tailed curve will be like this. Then you have one unskewed curve will look like this. Those curve, different kinds of shapes of the frequency curves. Line diagram, different kind of line diagram you can get. That's what is bell-shaped, J-shaped, and U-shaped frequency curve is all about. So next you want 24 and 25. LCB, that is lower class limits. LCB is lower class boundary. Abscissa I already told you. Please listen when I'm explaining. I told you in the x-axis, y-axis in the graph we have, that is called as abscissa. That's all, nothing else. The sides, x-axis, y-axis we have, that's called as abscissa. So 24 is done. 25. Dash variable is whose values theoretical can take infinite number of values. Infinite number of values, any number of values. That's why it's called as continuous series. For example, 10 to 15. It can be 11, 11.5, 11.8, 12.6. The number can be any number between the series. That's why it's called as continuous series. That was 25. Then 31. A relative frequency for a particular class lies between 0 and 1. This we told you. Relative frequency means that frequency divided by total. The frequency lowest can be 0 and highest can be total. So 0 by total is 0 and highest number is that number itself, that is divided by 1. And it cannot be 0 because if it is 0 we don't write any class interval. It cannot be 1 because you cannot have every frequency in one interval. Therefore it is between 0 to 1, but 0, 1 cannot be included. It is in between 0 to 1. That is relative frequency. That is 31, then 39th. Median of a distribution can be obtained from less than ogive curves. Ogive curves you are told. Less than also you can do, more than also you can do, intersection of that. That also you can do. From the less than type ogive curves, from the more than type ogive curves, or intersection of the two. All can be obtained. So that is median. Height of a person is continuous variable. Height of a person is again continuous variable. because it also again keeps changing. It's not a very fixed number. That's why. Next one you want 3940. Median we distribute. A comparison among class frequencies possible only in frequency polygon also we can compare, histogram also we compare. So both of them are right. So answer is A or B. 41. Frequency curve is a limiting form of frequency polygon and frequency histogram. In the sense, this frequency polygon what we get, that curve itself is called as frequency curve actually. So frequency curve is available in frequency polygon also, histogram also. In both cases we get the frequency curve. Because in the histogram also we get like this, right? This is histogram. So you see there is a curve which can be obtained here also. So frequency polygon also possible, histogram also possible. Then 48. A sample of study that revealed women were 40% of percentage were coffee drinker, 45 as a whole, and the percentage of male coffee drinking was 20. What is the percentage of non-coffee drinker? So answer comes to 15. This is the table, you can check it. How to understand the meaning of or and in a question. Or means either of them is right answer, you can't have both of them. Both means you can fit in first one as well as second one. I think this or and are more of your law interpretations more than here, but answer can be either A or B. That's how we select. You cannot have both answers. So whenever you say or, only one of them can be correct. And means both of them are correct. So that's a simple English meaning only. Or mean only one of them should be correct. And means both of them should be correct. Okay, then this is the table. Hope you got the table. You wanted 49. Cost of a sugar in a month, heads raw materials, direct labor production, others were 12, 20, 35, 23 units respectively. What is the difference between the central angles and the largest and smallest components of cost of sugar? So they have given 12, 20, 35, 23, that is total is 90. But if you are converting it to a degree, degree means you need to know that total should be 360. So what you should do, cross multiplication. 12 out of 90 for 360 how much? So you cross multiply 12 into 360 divided by 90. Like that you get 98, 90, 140, 92. Largest is 140, smallest is 48. 140 minus 48, you get 92. Okay, that was 49th. Then 54th. Frequency density for the intervals. Okay, these are the frequency densities we have got. These are the answers. If you prepare the limits, you get frequency 9, 11, 7. Width is 10, 10, 10. So you get 0.9, 1.1, 0.7. Okay, then 5960. What is the lower class boundary for interval thousands? For lower class interval but 1000, class boundary means you have to convert this into boundary. So minus 0.5 for the lower one, plus 0.5 for the upper one. So 1000 minus 0.5, you get 999.5. 70ths. A graph is a pictogram. Graph is all of this. A graph will contain basically pictures and so on. Picture, diagrams, graphs, everything put together is a graph. 35 is the larger number. In the 35 is a larger number in the sum 49. I don't know. What does that mean? The difference between the larger and smaller, that's the asking. The difference is what they're asking. So largest is 140, smallest is 48. So 140 minus 48 is 92. "35 are all numbers. You have to convert it to degrees. They're asking angles. So you should convert it to total degree 360. I told you pie chart, total degree will be 360 degrees. So corresponding to 150 we had got 140. Corresponding to 35 we got 140. And the lowest 12 we got 48. And difference between the angles. 140 is angle, 48 is angle. Okay. Then 73, 74. While computing mean of group data, we assume frequencies are centered at class mark of the classes. We assume it is equal to mid value. We did problem also. When the range is 0 to 10, we compute 0 plus 10 divided by 2, 5. That's what it is, centered at the class mark. It's also called as the mid value. The curve drawn by taking upper limits of x-axis and cumulative frequency along y-axis is called as the less than ogive, because we take the upper limits. So when I say 0 to 10, 10 to 20, 20 to 30, we say less than 10, less than 20, less than 30, like that. That's why it is joined by upper limits. That is what is less than ogive curves. 54th I have shown. 54th I had already shown. Okay, I'm showing it once more. Okay, next 78, 79. The abscissa of the point of intersection. I told you the point on the axis is called as abscissa. Intersection of less than, more than, that we told you. Less than intersection, more than intersection is median. Olive, are you registered first of all? I'm getting a message that you are not registered. Olive, can you please confirm? Are you joining with some other account? Asked you a question, also you're not replying there. Okay, 78, 79. Akash, please stick to the point what we're discussing. We are discussing the homework answers and you are talking about the past examination. We cannot keep moving from one point to another. Let's focus to the point what we're discussing. In the 54th, options are different, is it? Okay. Let me look at the option 54th. What we had got. Options. We got 0.9, 1.1, 0.7. That is the answer, right? 0.9, 1.1, 0.7. And previous answer, question paper, you don't get it. It is not available in the websites. Previous question papers are not available. Foundation, you may get it, but CPT, you don't get it. But I think Institute don't publish the previous year question papers. Okay. So what is pending? 79, 80th, hope we have discussed. 80th, okay. The visual representation of frequency distribution where frequency are represented by adjacent bars are called as histogram. That's what we told, histogram. We do it like this, adjacent bars. That's what is histogram. Last one, 90th. The width of each of the 10 intervals, the distribution is 2.5. Lower class frequency is 10.6. Which one of the following is the upper class boundary of the highest class? So 10.6 is the lowest point and the width is 2.5. So you can add 2.5, 2.5, 2.5. So basically if I add 25, the last number, highest number will become 35.6. So that's why it is 35.6. Because you start from 10.6, you keep increasing by 2.5, 2.5, 2.5, you do it 10 times. So that is how you get the last one, 35.6. Okay, so any other doubt relevant for this chapter you can ask. Any other topic like that graph, this graph, any of those doubts if you have anything? Because one of you told in the previous session that you had on some doubts in the statistical description of data, you can get it clarified. You want one more question? 81. Relative frequency. Relative frequency is that number divided by total. 9 divided by 30. 9 by 30 is 0.3. Marks allotted to this chapter, I told you around 3 to 4 marks. Statistical distribution, very simple, very small chapter, around 3 to 4 marks. Not too high, but that is the range, 3 to 4 marks. Okay? Any other points? Okay. '43. Distribution of a profits of a company follows bell-shaped curve. I have explained this in the earlier session. You will have the like this bell-shaped curve. Some years company makes very high profits. Some year company makes losses. Most of the times they are around the average. I discussed while discussing the skewness point. I discussed this point. Most of the times you will have average. Sometimes they make good profits. Sometimes they make losses, but on an average they take a medium profits, bell-shaped curve. Okay, hope it is fine. It can be based on any measure. It can be based on any measure. People enter in a mall is continuous variable. I think we have discussed this. People entering in a mall is continuous because the number is not fixed number. Skewness can be based on any arithmetic mean, but it's basically based on mean. Skewness is compared to mean, how the variables are distributed. That is called as skewness. Presentation, I've closed it. That's why it is black. Okay, I'll move further then. Okay. Okay, so what we were discussing, we discussing about measures of central tendency. Central tendency means we have so many values, we have a distribution of values. What is that one number which is a representative of all numbers? That is what is central tendency. Now we are trying to understand how different the things are. How different in the sense, when I compare values to the average, how different you are. That is called as measures of dispersion, or also called as measures of scatterness. Take a look at this example. A batsman A scores like this: 0, 0, 150. What is his average? 0 plus 0 plus 150 divided by 3. Average is 50. What is the average of this person? 50 plus 50 plus 50 divided by 3. This is also 50 only. You see, both of them have got same average, same measures of central tendency, but who is more consistent here? Obviously, you can see batsman B is more consistency. We need a measure, right? We need a measure for that. So measure of central tendency will give you average. But we want to understand how different the values are. The difference in the values comes from this measure, measures of dispersion. Measures of dispersion. Take a look at this one. Company A, company B, which is more volatile? Which share price is moving fast? You see this 20, 21, 21, 21, 20. This is not moving much. Company B share price 30, going to 199, coming to 10, going to 490. That the values are fluctuating. This values of fluctuation, scatterness, movement of distribution is called as measures of dispersion. To put it into simple words, measures of central tendency means how similar things are representative. Measures of dispersion means how different things are. For example, if I ask you, given a choice, which one would you do? Would you like to be an employee, or would you like to start your own business? You might have your own choices, but tell me, which is more riskier? Salary is more riskier, or working in a business? I mean, salary is more riskier or business is more riskier? Obviously, business is more riskier. Why it is riskier? Because it fluctuates. Correct? Now, this is a theory. But how much it fluctuates? How much it does not fluctuate? We need a measure for it. That measure is called as dispersion. That number, how much different, is called as dispersion. The same thing we can apply in batsmen also. You see cricketers, some batsmen scores, when they play very well. See, here now I don't know, but there is one person called as Sehwag. You know how he used to play? Fearlessly. He scores 100 plus, India wins the match. Otherwise, he will get out for 0 also. He is the batsman who scores, and for the ball 1 only, he hits 6. Second ball, he can get out. He's so fluctuating. I'm not saying good or bad, but definitely he is more riskier. You see Rahul Dravid, he does not score too much, but he's always more consistent. So you understand, right? The 2 points, we don't talk about the average here. We want to understand who is more reliable, what stock is more riskier, which nature of a business is more consistent, more stable. The consistency, stability, variation, movement, the range is measured by dispersion. Okay, so now when you tell in BCom exams, let's say after BCom exams, people will ask you, how much marks you think you get? After the exam, based on performance, you say, I can score about 80 plus. And your examination marks will be around 82 or 75, in a range in that. In CA exams, if somebody asks you, how was the exams? Let me tell you. The reaction of a doctor after performing operations, when he's walking out of the operation theater, and a CA student walking out of examination, both are same. When relatives of the patients ask, so doctor, what happened to the patient? How was the operation? What does doctor will tell usually? I have tried my level best. Rest is up to the God. CA students also will tell the same answer. I tried my level best. Marks up to the God, meaning ICAI. So, if you tell, I can get around 65 plus, in reality, it can be 12 marks also, it can be 80 marks also. So much variation, so much risk, so much inconsistency. So much inconsistency. Now, in general, we can talk about these inconsistency variations, but we need a statistical parameter to measure. That's called as measures of dispersion. This dispersion basically measures. It measures variation. It measures variation. How things are different. How values are different from arithmetic mean. Deviation. The deviation measurement is called as dispersion. Okay. So that is what the main objective. Types of it we have. Like we have absolute measure. We have relative measure. Elements are there. We should understand all of these items. But let me give you a basic meaning of it. Absolute measure means it is with units. What is units? You will tell marks, rupees, kgs, kilometers, like that. You use units. Now units when you have, you can't compare it. Now can I say which is higher? 1000 kg is higher or 1 lakh is higher? 1 lakh rupees. Can you compare? A kg and rupees cannot be compared. So absolute measure cannot be used for comparison. To make it comparable, we will express in percentages. That is called as relative measures. So what is the main purpose of relative measures? Relative measures are without any units. They are expressed in percentage. What is the purpose of relative measure? To make it comparable. When you want to compare and say which is more riskier, which is more consistent, we need to compare. The comparability comes from relative measure of dispersion. So main purpose of relative measures is comparison. What is the main purpose of your relatives? Comparison. So in English, whenever the word relative comes, what else comes? Comparison. Relatives means comparison, whether in life or in our theory. Relatives means comparison. Okay. The simplest dispersion we have is called as range. So range is simple formula. You say highest minus lowest. Highest minus lowest. That is the range. Now, where do you think range is used? Range is used usually for all estimations. Now, standing today, if somebody asks you, how much marks you think you get in CA exams, in quant, you'll say, I'll score about 60 to 80 marks. You will not tell, I'll score 79 marks exactly. You will not know in advance. So whenever you want to do estimations, range is used. Before we go to the problems on ranges and all, I'll quickly discuss the other types of measures also. Then we do all the problems together. Okay? Now, range. Range is highest minus lowest. So, for example, marks of a student is like this. Marks of a student. He has attended various tests. His marks are 20, 40, 60, 70, 100. So, what is the range? 20 to 100. You also understand, sometimes you speak, no, that person, his range itself is different. That means he is in a different league. His minimum number is different. So we say the range, minimum to maximum, the difference itself is at a different league. Here we say range is 80. And coefficient of range to express in percentages, range is highest minus least, and coefficient of range is given by highest minus least plus highest plus least. Difference divided by sum. That will give you the total range multiplied by 100. So we get the answer in percentages. Coefficient of range is not much in use, so don't worry about it much. But range is used in so many places. Let's understand the important property now. Please pay focus here. Important property now. Very important property. Okay. Now 20, 40, 70, 100 we have. All of this I increase by 2 each. All of these I increase by 2 each. Plus 2, plus 2, plus 2 like that. What is this concept is called as? Increasing the observations. Increasing the observation of each number by constant amount. What is it called as? Change of origin. Change of origin. Change of origin. And tell me what is the range here now? Least was 20, highest was 100, so range was 80. Correct? Now, after making this change of origin, what is the new range? What is the new range? This is 22. This became 102. 22 to 102. It's still 80 only. You observe, before the change of origin also it was 80. After the change of origin also it is 80. So range is independent of change of origin or dependent on change of origin. When the origin changes, what happens to the range? Range don't change. Range don't change. When you don't change, you are called as independent. You are called as independent. You remember arithmetic mean, median mode, everything was dependent on change of origin. But all these, range also, the all others we discussed, measures of dispersion, mean deviation, standard deviation, everything, quartile deviation, everything is independent of change of origin. That is, origin may change, range don't change. So if I tell you like this, y equal to, let's say, x plus 2, and range of x is 10. Can you think what is range of y? Y equals to x plus 2. Range of x is 10. What is range of y will become? It will not become 12. It will not become 12. Are you understanding? It is independent of origin. Range don't change. Even when you add 2, values may change. Range don't change. Which means the constant should be ignored. Constant should be ignored. You can say y equal to x plus 2. But we say range of x equal to range of y. This plus 2 don't change. Range of y equal to range of x. Plus 2 we don't apply because values may change, but range don't change. When you increase every observation, then also range will remain same. In very important property of range, independent of change of origin. Not only range, quartile deviation, mean deviation, standard deviation, everything what you are going to discuss will make sure that the values don't change when you increase or decrease. Multiply, we'll look at it now. So it is independent of change of origin. Let's take same example like 10, some numbers we have 10 dot dot dot. Highest number we have, let's say 90. So what is the range we have? 80. Now everything I multiplied by 2. So minimum 10 into 2 became 20. 92 into 2 became 180. What is the range now? 20 to 180. The range is 160. What happened to the range? What happened to the range? Range changed. 80 into 2 becomes 160. So now tell me, range, what is this concept is called as? When you multiply, this is called as change of scale. Change of scale. And range changed. When range changed, range is called as dependent on change of scale. Central tendency was dependent on both, but range is dependent on scale but independent on origin. What is the meaning of this? If I give you equation y equal to 3x plus 2, if I tell you range of x is 10, how much is range of y? Can you tell me how much is range of y will be? It will not be 32. I just told you now. This plus 2 will not be having impact because the values may change. The range don't change. So plus 2 should not be done. Plus 2 should not be done. Plus 2 should be ignored. But multiply by 3 should be considered. Multiplied by 3 should be considered. So 10 into 3, that becomes 30. So y equal to 3x plus 2. Plus 2 means it is change of origin. Multiplied by 3 means change of scale. And range is independent of origin. Range is independent. Therefore, this we have to make it as 0. But range is dependent on change of scale. Range is dependent on change of scale. Therefore, this 3x continues. So if x equals to 10, range of x equal to 10, you do 3 into 10 equals 30. 3 into 10 equals 30. Did you get the point? Change of scale, change of origin. You can write down this example for your reference. Write down this example. Write down this example. Okay. So range is done. Coefficient of range is done. Now let me tell you next concept. This is range. What is the formula for range we have written? Highest minus least. Now I want quartile range. Range in quartile. Range in quartile. What is the highest range? What is the highest quartile? Remember, what is the highest quartile? Q3 minus Q1. This is called as range in quartile. And we have something called as semi quartile range, semi-inter quartile. Semi-inter quartile is given by just half, Q3 minus Q1 divided by 2. Q3 minus Q1 divided by 2. Semi-inter quartile range. So range is Q3 minus Q1. Semi means half. So half of Q3 minus Q1. This is also called as quartile deviation. This is also called as quartile deviation. Called as quartile deviation. Quartile deviation. Quartile deviation. Okay. The properties of range will apply to properties of quartile deviation. Now tell me one more question. Can range be negative? Can range give you negative value? Can range be negative? Never. No. Range is always positive because highest minus least. Highest minus is always more. Lowest number is always less. At worst case, it can be equal. So you can never get a negative range. Tell me now, can you get a negative quartile deviation? Can you get negative quartile deviation? Can you get negative quartile deviation? The answer is again no. You cannot get because Q3 is always more. No. How Q1, Q3 is obtained? Array. What is array? Arrange from least to highest. Arrange from least to highest. So Q1 is always less. Q3 is always more. So quartile deviation is also positive. And the property of change of origin, change of scale applies here also. Then we have coefficient of quartile deviation. Coefficient of quartile deviation. Again, this is not in practice, but syllabus it is there. I'll tell you. So Q3 minus Q1 divided by Q3 plus Q1 into hundreds. Just like the way we do for range. H minus L by H plus L into 100. Here also. Q3 minus Q1 divided by Q3 plus Q1 into 100. Into 100. Okay, now we'll come to the most important discussion on this one. Please pay focus here. Let's take an example and understand. You also write down the example with me. Marks of 3 students are like this. Let's say marks of 3 students are like this. Marks of 3 students 60, 70, 80. Marks of 3 students. So how do you calculate the average here? X bar 60 summation x divided by n. 60, 70 plus 80 divided by 3. How much you get? 70. 70. Right? Now I am telling the marks of three students in the class, their representative is 70. Now, what does X will tell you? First person will tell you, no, I am not happy with that number. I have got less than 70. So what is the deviation? This we call it as X minus X bar. Hope you remember. This is called as deviation. X minus X bar. So 60 minus 70. That is minus 10. What is the meaning of minus 10? It is below average. Now this is how much? 70 minus 70 equal to 0. Okay. So this is 0. Then 80 minus 70, that is equal to 10. What is this called as? These are called as deviations. These are called as deviations. So minus 10 is below average, 0 is equal to average, and plus 10 is above average, but deviation. Now tell me this. Can I say this 60 and 80 are equidistant from this number 70? They are equidistant in the sense one person is below average, other person is above average, but deviation is deviation. So minus 10 is also deviation, plus 10 is also deviation. So you are driving vehicle, you take left is also deviation, you take right is also deviation. Both are deviations only. So what do we do? Let me ignore the signs. I want just the deviation. I call this like this symbol, absolute number. I ignore the minus sign because minus is also deviation, plus is also deviation. So I want only deviation. So 10, 0, 10. Total becomes 20. What do you think we can call this? What is the name? 10 is called as deviation. 0 is called as deviation. 10 is called as deviation. So what is the total is called as? Okay, I'll give you a hint. This is 60 marks. This is 70 marks. This is 80 marks. So here we called as total marks. Total marks. 10 is deviation. 0 is deviation. 10 is deviation. When I do the total, can I say it is sum of deviation? It is called as sum of deviations. Correct. It is called as sum of deviations. Okay. Now back to basics little bit. How did we compute average marks? Average marks. How did we calculate? Formula we did. Can I write like this? Please tell me. Can I write like this? Average marks is sum of marks divided by number of students. Is it correct? Sum of marks divided by number of students. Sum of marks divided by number of students is called as average marks or mean marks. Now, sum of salary divided by number of employees, what is that called? Can you tell me? Sum of marks gave us mean marks. Sum of marks gave us mean marks. Sum of salary divided by number of employees will give me what? Mean salary, right? Mean salary, average salary, mean salary. Mean salary. Now tell me, if I do sum of deviation divided by number of students, what do I get? Sum of deviations divided by number of students. That is what is called as mean deviation. Hope you got the logical aspect of this. Mean deviation is given by sum of deviation divided by number of observations. And how did we get sum of deviations? We ignore the negative signs. This formula is summation x minus x bar absolute, we say absolute means no negative, modulus divided by number of observations. So we learned range, we learned quartile deviation, and we learned mean deviation. So how do we compute mean deviation? We compute the deviations first. We compute the deviations first. Then we ignore the minus signs because I want absolute deviations. Then I do the total of it. The total is called as sum of deviations. It's called as sum of deviations. Then I divide by n. What do I get? Average deviation, mean deviation. So it is called as mean deviation. Now to be specific, this is mean, right? This is mean. Now tell me this. Since I have computed mean, is that why it is called as mean deviation? Since this is deviation from mean, is that why it is called as mean deviation? I've calculated mean first. Is that the reason it is called as mean deviation? The answer is no. It's called as mean deviation because I have added all the deviations. We have added all deviations and then we divide by n. That's why it is called as mean deviation. So logically, mean deviation can be from mean. Mean deviation can be from median. Or mean deviation can be from mode. Mean deviation can be from mean. Mean deviation can be from mode. Mean deviation can be from median. Deviations can be from mean. Deviations can be from median. Deviation can be from mode. Deviation can be from anything. Deviation means deviation from central tendency. In generally, we say average means arithmetic mean. So generally we say deviation means from mean, but theoretically it's not. Theoretically, deviations can be from mean, deviations can be from median, deviations can be from mode. And under each cases, answer is differing. Answer is different. Different measures, different numbers, different interpretations. Okay, you got the one. Now deviations, mean deviations. We compute deviations normally from mean, but not always. Theoretically, it can be from median also. Theoretically, it can be from mode also. Hope you have written the example along with me, logically also. Yes? Okay. Okay, now I'll go to one step further now, then we go for problems. Coefficient of mean deviation is also there, not much very important practically. So exam wise it's there, we'll solve problems, but we'll focus on now most important formula, theoretically, examinationally and practically. Most important formula. Listen to me this carefully. If you have 30 by 40 site. If you have 30 by 40 site, okay, then you have nearby site 10 by 20 sites. 10 by 20 sites. Now can you tell me what is the sides of the combined area? Combined area. One site plus another site. What is going to be combined area? Can I say is it going to be 30 plus 10 or 40 plus 10? We don't do neither like that. We don't do neither like that. What do we do? Have I told adjacent? This 10 by 20 can be this side also, this side also. No. So what do we do? 30 by 40 is 1200. 10 by 20 is 200. So 1200 plus 200, 1400 square feet. Correct? So total area is 1400 square feet. Whether 10 by 20, 20 by 10, square feet is square feet. Area is same only, this way or that way. Whichever way you see, area is same. What is the important discussion on this point? When you want to know the values, don't look at the sides, look at the area. Look at the area. And how do you find out the area? By multiplying the length and the width. Now, what is the example I have taken? Marks of 3 students. I forgot the numbers. What are numbers we have taken? Tell me the numbers. In the example we just took now. 3 numbers we took. 60, 70, 80. Okay. So if I represent in graph, okay, 60 will be like this, 70 will be like this, 80 will be like this. And I got an average as somewhere here. This is the average. So when I do 60 to 70, I get like this, right? That is what is minus 10. That is what we say x minus x bar equal to deviation. And it was negative because it was below average. You can see in the graph also. Now I want to not add the deviation. I don't want length. I don't want length. I need the area. If one side is 10 centimeters, how do I know the area of it? Equal sides are there. How do I know? If one side is 10, how do I know the area of this completely? One side is 10. Let's say all side is 10 only. Can I do 10, 10, 10, 10, 40? No, I'll multiply. 10 into 10, it becomes 10 square. Forget about this part. So we have 60, 70, 80, right? So total we had got whatever the average, x bar we got it as 70. Then we calculated x minus x bar as 60 minus 70 minus 10, 0 plus 10. Now pay focus. This was deviation, means length. This was deviation, is length. I will convert this into area. How do I convert this into area? I am going to square it. X minus x bar whole square. That becomes area. What is minus 10 into minus 10? Side also minus 10, this also minus 10. Minus 10 into minus 10 becomes 100. This anyway is 0. This becomes 100. Now total is 200. What is this total is called as? This is called as sum of area of deviations. Sum of area of deviation. You know what is this called as? Summation x minus x bar. Summation x minus x bar. Now tell me this. This is sum of area of deviation. I want average area. How do you think we can get? Sum of area of deviation I got. I need average. How do I do the average? I know the sum. From the sum, how do I convert it to average? Divided by 3. Divided by number of observations. 200 by 3. That is average area of deviations. Average area of deviations, you say 200 by 3 number, that is 66.67. But what is the formula wise? Summation x minus x bar whole square divided by n. This is called as variance. This is called as variance. Now this is average area. Now I want the length back. I want to go to the length back. How do I go back? Please observe. This 10 square I did, I got 100. So from the length, I squared it, I got 100. But if I want to go back, from the 100 I want to go back, what do I do? I'll take a square root. So do square root of 66.67. Square root of 66.67. 8.164. 8.164. This square root of summation x minus x bar whole square divided by n. You know what is this called as? This is called as standard deviation. And this is average length of deviations. Average length of deviations. Anyway, this is the concept. So much we discussed, so much things you don't have to worry, conceptually I have to tell, but this is the most important measure I can say, standard deviation. Till today, in stock market, it is used in so many places, people are not aware of it. So the most widely used throughout the world, in so many places, the measure of, when I say average, I mean arithmetic mean, right? I know different measures are there. Still, most popular average is arithmetic mean. Like that, most popular deviation, most widely used, most widely accepted throughout the world is standard deviation. Standard deviation. Please write down. Please write down. Then I'll give you the formula also. Then we'll give a comparison also. This symbol is also there. Okay, we'll write down this symbol, standard deviation. We use this symbol. Sigma also some people say. Sigma, symbol, whatever it is. Please write down this and let me know once it is done. There is nothing called as most accurate answer, but among the things available, this is the widely accepted one. Among the various measures available, none of them is accurate, but accepted one is this. Done? Okay. Let's write down the formula quickly. This is the most important one. Let's write down the formula. Standard deviation or we say SD, or some people use the sigma symbol. It's given by square root of summation x minus x bar whole square divided by n whole square root. Okay, and what is the meaning of this? This is to be interpreted as average length of deviation from mean. Average length of deviation from mean. Then variance is same formula but without square roots. Summation x minus x bar whole square divided by n, or some people also say sigma square, or standard deviation can also be calculated as square root of variance. Okay, so if I tell you x bar is 20 and sigma is 5, what is the meaning of this? If I say stock market, since I do it, most of the transactions, I'll give that as the example. From a stock, first year it gave me 25% return, next year it gave me 30% return, next year minus 12% return, so rate of return average. So rate of return average gave me 20%, standard deviation gave me 5%. So what does it mean? Next year, expected returns is most likely to be 20 because I've taken the average. I've taken the average. Then plus or minus 5. Plus or minus 5. So the range can be plus 5 or minus 5. From the mean, plus upside how much it can go. From the mean, downside how much it can go. That is given by variance. That is given by standard deviation. Given by standard deviation. So average is 20. Length of deviation from the mean is 5. Correct. That's the interpretation. But from mean means how much? 20. It can be plus 5 or it can be minus 5. Both sides. So it can be, most likely it will be 20, but it can be plus 5 or it can be minus 5. That's how we also express, no, normally. How many years do you think you can be alive? Humans. How many years you think you'll be alive? 60 plus or minus 5 years. You understand? 60 years I will live. Plus or minus, I don't know how much happens. It can be minus also, it can be plus also to an extent. So we give a number, then we give a range around it. The number we give is called as average. The number we give around it, that's called as standard deviation. Called as standard deviation. So basically, mean deviation is based on absolute difference, whereas standard deviation depends on the areas, then converting it to deviation. Okay, got the point? Okay, one more is there, that is called as, that is also important. COV, coefficient of variation. Coefficient of variation, that is given by standard deviation by mean into hundreds. Standard deviation by mean into 100. It means lower the COV, lower the coefficient of variation, higher the consistency. Higher the consistency. Lower the variation, higher the consistency. And this is expressed in percentage. Mean by average into 100. And standard deviation is always from mean. It's only from arithmetic mean, nothing else. No median mode and all. It's always from mean. It is coefficient of variance. We say coefficient of variation. Coefficient of variance. Correct. Coefficient of variance. COV is coefficient of variance. Coefficient of variation. Coefficient of variance. COV is coefficient of variation, coefficient of variance. Coefficient of variance. Okay, is it done? Okay. Yes. Let me just write all the things we had. Range. We had coefficient of deviation. Why coefficient lowest the COV is highest the consistency? Because we are getting numerator what? Standard deviation. Standard deviation means variation. Higher the variation, lower the consistency. No, if you vary too much, If you vary too much, lower the consistency, and lower the variation, higher the consistency. You get the point? Simple one. See, there are some set of people, when you tell little bit, they react too much. For small things also, they react too much. Too sensitive people. That means for them, higher is the variation, lower the consistency. And for some people, never react. Whatever you tell them, they don't react. They are lower the coefficient of variation, but higher the consistency. Very simple concept. Okay. So range, quartile deviation, then mean deviation, then we have standard deviation. These are the four measures. Now, signs. We discussed range is always positive. Range can never be negative. Quartile deviation is always positive. Now tell me, mean deviation, can it be negative? Can mean deviation be negative? No, mean deviation can never be negative. Why? Because we always take positive number, no absolute values. We ignore negative signs. Modulus, absolute, yes. So mean deviation is also positive. Mean deviation also positive. What about standard deviation? Can standard deviation be negative? Can standard deviation be negative? Answer is no. This also is positive. We square it. A number, we square it. And when you square, answer is always positive. Or a square root, answer is always positive. So negative you cannot get. Therefore, in general, we can say all measures of dispersions are positive. It can never be negative. Similarly, origin change, change of origin, change of scale. All of them are independent. Independent of origin, independent of origin, independent of origin, independent of origin. In general also we can say it is independent of origin. All measures of dispersions are independent of origin. But scale, all are dependent. All are dependent. Means everybody will change when you multiply. But when you add, they don't change. So just write down this table. Write down this table. Done? Okay. Okay. After all this, what is the important interpretation? Please observe. Important interpretation. Important interpretation. If I give you equation y equal to 3x plus 2, what does it mean? Constant should be ignored, multiplier should be considered. For what? For range, for quartile deviation, for mean deviation, for standard deviation. Did you get the point? Let's write down the sentence. So when equation is given, ignore the constant but consider multiplier. Ignore the constant but consider the multiplier. But why should you do it? What is the logic? Ignore the constant because constant addition means change of origin. So all the measures of dispersions are independent of origin. But we consider multiplier, that is, it is dependent on scale. Dependent on scale. One more important point. Suppose you get the number, after all simplification, as -5. You know what you should do? You should compulsorily make it as +5. Why? Because all measures of dispersions are always positive. So even if you get a negative answer, ignore the minus sign, blindly select the option as +5. And in the exam, they'll give you minus also, plus also to confuse you. You should be careful. So if negative answer comes, ignore the minus sign. Ignore. If negative number comes, ignore the minus sign. Ignore minus. And why? Because all measures of dispersion are positive. For this reason, you have to exclude. All measures of dispersions are positive. All measures of dispersions are positive. Got it? Any questions? Any point I have to explain? Done? Okay. Only what is left out is we have to solve problems now. That's all left out. Okay. Yeah. Illustrations and problems. Okay. Before that, we'll take a break. Take a break of 20 minutes. We'll meet after 20 minutes. Take a break of 20 minutes. 20 minutes break. Okay, so we have discussed the theoretical parts. Let's go to problems now. Okay, so PPT is visible, voice is clear. You want the charts? Okay, this was the charts. Okay, let's go for problems. Find out the range of the given distribution 1, 3, 5, 9, 11. Highest minus least, highest is 11, least is 1, so it is 10. Simple one, 11 minus 1, that is the range. Next, from the following data, calculate the range. Can you compute what is the range for this one? Okay, the answer is 60, because when I say range, it is range of marks, not number of students. Highest is 60, lowest is 0, 60 minus 0, 60. That happens. That is a common mistake people do. Be careful. Okay, next. Next one. From the following are the marks of 10 students. Find the quartile deviation and also its coefficient. Okay, first you build an array. Arrange from least to highest. Arrange from least to highest. Okay, so quartile deviation we have arranged from highest to lowest to highest. Then we compute the quartile deviation, means I need two things. Q3 I need, Q1 I need. Q3 minus Q1 divided by 2. So go for it. Q1, n plus 1 by 4. Number of observation 10. 10 plus 1 by 4. 2.75. 2.75 means second observation as it is plus the decimal. The decimal is 0.75. Then difference between next two terms. Next two terms are third term and second term. That is, third term is 48, second term is 42. So 48 minus 42. So 42 plus 4.5, that is 46.5. Q3, n plus 1 by 4 into 3, n is 10, 10 plus 1 by 4 into 3, 8.25. 8.25 is calculated as 8th term as it is plus 0.25 into next two terms, 9th minus 8th. 9th term is 75, 8th term is 65, 9th minus 8, 75 minus 65. Quartile deviation, Q3 minus Q1 divided by 2, 67.5 minus 46.5 divided by 2. Divided by 2. You get 10.5. Coefficient of quartile deviation also asked Q3 minus Q2, Q3 minus Q1 by Q3 plus Q1 into 100. Q3 minus Q1, 67.5 minus 46.5. Q3 plus Q1, 67.5 plus 46.5 into 100 to express in percentage. Okay. Moving on. Hope you got it. Next. If x and y are related, oh, your x and your y are related, it seems. 3x plus 4y equal to 20, and quartile deviation of x is 12, quartile deviation of y is. So equation is 3x plus 4y equal to 20. What is the important information, my dear friends? I told you quartile deviation, range, mean deviation and standard deviation are independent of origin but not scale. Therefore, the constant should be ignored. So 3 into range of x plus 4 into range of y, and the constant will make it as 0. Constant will make it as 0. And quartile deviation, it's not range, quartile deviation, no problem. So quartile deviation, not range, quartile deviation. Okay. Now quartile deviation of x is given as 12. So 3 into 12 plus 4 into quartile deviation of y equals 0. So 3 into 12 is 36 plus 4 into quartile deviation of y equals to 0. So 4 into quartile deviation of y equals plus 36 becomes minus 36, and quartile deviation of y minus 36 divided by 4, that becomes minus 9. But this minus 9, I will forcefully make it as plus 9, because quartile deviation, range, mean deviation, standard deviation cannot be negative. So ignore the minus sign on the last step. The quartile deviation, range, mean deviation, standard deviations, all are always positive. So in the final answer, even if you get plus 9, you make it as minus. Even if it is minus 9, you make it as plus 9. Okay, next. Following are the marks of 10 students. Find the mean deviation from mean and also its coefficient. Okay, so 10 students are there. Average, add all of them, divide by number of students, 56.8. Then you compute the deviation. How do you compute the deviation? 56 minus 56.8. 48 minus 56.8. 65 minus 56.8. Like that. X minus X bar. 56 minus 56.8. 48 minus 56.8, like that. X minus X bar gives you deviation. But we should ignore the minus sign because we are computing mean deviation. Total you get 109.6. So 109.6 divided by number of observation 10. That will give you 10.96. Please write down. $10.96. Write down slowly. Let me know if any number need to be explained. Okay, hope you are able to understand. Okay, so they've also asked one more thing. They've also asked coefficient of mean deviation. So we will do coefficient of mean deviation, coefficient of mean deviation, just like standard deviation, mean deviation divided by whatever is the base. The base is mean divided by mean into 100. So 10.96 divided by 56.8 into 100, always multiplied by 100 to express in percentage. You get 19.29%. 19.29%. Done? Okay. Next. Okay. So following are the marks of again same problem, but you have to compute the median and also its coefficient. So median arrange from least to highest. We have done it already while doing quartile deviation. Median n plus 1 by 2. 10 plus 1 by 2 means 5.5. That is fifth observation plus sixth observation. So 55 plus 56 divided by 2, 55.5. Then you compute x minus median absolute. How do you calculate? 56 minus 55.5. That is 0.5. Ignore minus signs, okay? So 48 minus 45.55.5, you get minus 7.5. Ignore the minus sign. You get 7.5. Like that, do the total. You get 108 divided by 10. That is 10.8. Then coefficient of mean deviation, 10.8 divided by median, 55.5 into 100 will get you 19.46%. Please write down. Let me know if you have any doubts. Nineteen point 459, you can say 46. Okay, hope you're able to do it. Why we are not taking average? This is from median, that's why. This is mean deviation from median. Therefore, all the deviations are calculated from median. Median is the average here. Median is the average here. The deviation is calculated from median. So all the values are subtracted from median. Values minus median. 56 minus 55.5. I have shown you the arrow. You'll be able to understand. The x values minus median. X 56 minus 55.5, 48 minus 55.5, 65 minus 55.5, 35 minus 55.5. The values of x minus median. Negative number comes, ignore it. Okay, next. Hope it is done. If x and y are related, again here x and y are related, mean deviation of x is 21. What is mean deviation of y? Let's do it fast now. 5x plus 4y equals to 40. This 40 will make it as 0. Ignore the constant. And x is 21. So 21 into 5 becomes 105 plus 4y equals 0. So 4y becomes 105 minus y is minus 105 divided by 4. How much you get? Minus 26.25. Even though it is minus, we will take only plus. Only positive number. 26.25. Only positive number. 26.25. Okay. One more point I forgot to explain. Um, in the previous problem we observed, the deviation can be calculated from median or deviation can be calculated from mean. Among the two, in fact, in general, you remember, the median always gives the lowest number. You can see in the previous problem also. So this we got 10.8 and here we got 10.96, right? So in general also remember the property, deviation from median is always the lowest. Why it is the lowest? Because deviation, I told you, distance. Median means it is the middlemost value, right? Physically middlemost value, more than number wise. Physically the middlemost value. Therefore, since physically it is a middlemost value, median always will be the lowest in terms of its physical deviation. That is why mean deviation is always lowest when you compute from median. Just an observation, no other concept beyond this. Okay, let's go further. Okay, following are the marks of 10 students. No, it can never be higher. Mean deviation, when I compare between median and let's say mean, median is always low because median is in between. No, physically it is in between, because we make sure median 50% left side, 50% right side. Since physically median is always middle, even the deviation also, the median will give you the lowest as compared to the others. Median only will be the lowest. Yeah, I just explained deviation relationship. I just explained between mean, median and mode. Median will give you the lowest. Mode mean any number can be there. There is no limitation, but the lowest is always median because it's physically median. The distance, mean deviation will measure physical distance, and this is comes in between, so that will give you the lowest value. Fine. Okay. Come to this. Following are the marks of 10 students. Find the standard deviation. Standard deviation means x minus x bar the whole square. This x minus x bar we already done. If you remember in the earlier mean deviation, we already done. I'll explain once more. 56 minus 56.8. That's how we get minus 0.8. 56 minus 56.8. Then 48 minus 56.8. Like that you calculate x minus x bar, but we require square, so square it. 0.8 square, 8.8 square, 8.2 square, 21.8 square, like that. Total square comes to 1866. So standard deviation, x minus x bar whole square, which is 1866. Number of observation 10 students, so 1866 divided by 10 equal to square root. One more time, which number? Tell me, I'll tell you. Which number you could not calculate? Which number? Third column, second column square. 0.8 square, 0.64. 8.8 square, 77.44. 8.2 square, 67.24. Like that. Square numbers. The second column is square, you get the third column. Yes, these sums will come for exams. These sums definitely can come for exams. For exams, yes, only MCQ question. This will have an option, that's all. Option 10, 12, 13.66, 14.42, options will be there. Same kind of question, options will be there. We have to note down these sums and make a separate notes for this. These sums are there in the material, only solution you have to take it down. All these illustrations are there in the material. All these solutions are there in the material. Only solution you have to take it down. Okay. Let's move further then. Square summation is coming in decimals. Okay, I have rounded it off. That's fine. Anyway, answer will be approximately. So answer is fine. 1865.6, you can take it. Answer will be very close only. So decimal wise, overall answer will not be different. For exam purpose, working column. I don't understand working column because sometime they will supply the material. Sometime you have to take your own worksheets for you to write it down. Okay. So now, one more alternate formula is there. That also will write it down. Alternatively, one more formula is there. One more formula is this. This is summation x square by n minus summation x by n the whole square. This also give you the same formula. For that I am doing it. This is faster in examination. That's why I am choosing this. Faster in exam, okay? Now, summation x square. What is summation x square? You should do x square, do the total, that gives you summation x square. See, I have done it here. Please check it out. 56 square. How do we calculate 56 square? (56 square means 56 into equals. Then 48 square. 48 into equals. 65 square. 65 into equals. Like that, you can compute for every number and do the total. This 568 is total of this summation x. This is x square column total. So you can do summation x square. And do you know, this x square column total you can do fast in your calculator without writing this. Some of you are asking, working column, without having this column you can do in calculator. Remember, you can do using m plus or you can do using GT. Both ways you can do. Let me tell you how to do using M plus. You get the practice of M plus also. We need square, right? So you do 56 into equals M plus. Next, 48 into equals M plus. Then 65 into equals M plus. Like that do for every number. At the end, press MRC. You would have got 34,128. Please do it slowly and tell me the number is coming, because this will save lot of time in exam. You don't have to write down everything. If you know how to make use of calculator, writing time is saved. Computation time is saved. So to do faster, you don't have to be Shakuntala Devi to do computations in mind. As long as you can do in calculator, at least then you can do. And if you can't do in calculator only fast, please don't think about doing it in your mind. Forget about it. Okay, hope you're getting it. Do it slowly. Do it fresh in case you're not getting. Sometimes what happens, you type it, you don't type it. So your hand will shiver. You will do 5 times once more. All those things will happen. I hope you got it. 3, 4, 1, 2, 8. Do it slowly in case you're not getting it. The process, I have written it here. If you want, you can write down somewhere. You can write down here. In the exam, you don't have to write it down. Just have to use the calculators. Okay. You can also do it using GT. If you have calculator, GT, how you can do? M plus is not required. You can simply do like this. 56 into equals 48 into equals 65 into equals. At last, you can press GT. You need not press M plus MRC also. Just by GT, you can get it. Just with TT, you can get it. You will be able to get it. Just with GT, you will be able to get it. Are you getting it? Please try in GT also. Yes, you got it. Again, GT will save even more time, because M plus also you don't have to do. But you should always start fresh. GT means you should always start fresh. Clear calculator memory, on, AC, clear, whatever it is, and you can start fresh. Then you will be able to get it. It will be faster. Yes? Good. Again, if you don't have a calculator GT, you can do M plus, but it's better you buy a calculator with GT. Okay, let's substitute now. 34128 is summation x square. Number of observation is 10. 568 is summation x. Number of observation is 10. So 342128 by 10 is 3412.8. 568 by 10 is 56.8. And 56.8 square is 3226.24. Then take a square root. You get same number, 13.66. You get the same number, 13.66. Now GST is different, GT is different. GST means tax, that is different. GST will not be useful. GT means grand total. So your calculator will not, you don't have GT. GST will not be helpful for us. You learn GST when you come to intermediate and final. There you learn GST. But here GT means only GT. That's not GST. Okay. Now, this calculation you can bring down to one step. Directly you can do it in calculator if you do the calculation properly. First, I will tell you. Let's see if we get the answer. Then each step I'll explain with the logic. We'll do slowly, no problem. Fine. Please follow what I say now. Start fresh in the calculator. Start fresh in the calculator. 34128 divided by 10 34128 divided by 10 equals to m plus. Equal to m plus. Okay. 568 divided by 10. 568 divided by 10 into equals m minus mrc square root. M minus mrc square root. Are you getting the answer? You got it. Very good. Amazing. Nice. Calculator is working correctly. Now you should understand how the calculator works. So it will take 2 minutes to learn, but it will save time in the exam. So let's spend that time. Now I'll write it. You do it slowly with the logic we'll get. So we need this number. So we did 34128 divided by 10 equal to m plus. Start fresh, clear the calculator memory, do this. 34128 divided by 10. You get 3412.8 equal to m plus. So it got added to the calculator memory. 3412.8 answer you got. When you pressed m plus, it got added to the calculator memory. Then we wanted second part of the number. So what do? 568 divided by 10. You would have got 56.8. But what we require square, right? And how do we compute square in calculator? Into equals. When I did into equals, it got squared. It got squared. Then I want to subtract this. This number should be subtracted from which one? It should be subtracted from calculator memory. And how do we subtract? By doing m minus. By doing m minus whatever is in the calculator memory. And what was in the calculator memory? This 3412.8 was calculator memory. Now what you did? 56.8 into equals to, you squared and you did m minus. That means whatever 3412.8 was there, that got subtracted. Now you want to see what is in the calculator memory. For that purpose, you press MRC. That will give you actually 186.56. But we need a square root. So on the last step, you do square root. You do square root. Quickly do it once more. Quickly do it once more. Start fresh. Clear calculator memory. On MRC 2 times. Clear MC, whatever it is. 34128 divided by 10 equal to m plus 568 divided by 10 into equals m minus MRC square root. M minus MRC square root. Just getting in the calculator is not sufficient. You should also do independently for some other problem. You should learn that. Got it? Hope you understood the logic, not just the calculations, how the calculator works. See, instead of spending time on understanding your friend who might change the behavior anytime, you make yourself calculator your friend. And your friend, calculator, will come with you in examination also. Nobody else will come with you. So it's better to understand the calculator than anybody else. So make yourself comfortable, a friend with calculator. Don't make yourself comfortable with your friend's calculator. When in the class I used to see it, people used to use others' calculator and do it. Don't do it. Use your own calculator and learn how to use it. How do we talk to Calci? More than important, when calculator is telling, try to understand how the calculation works, how the calculator behaves. Then don't blame calculator for it. I've seen students, when you're not getting the answer, you take your frustration out on calculator. In the class I used to see, answer is not getting, you do like this calculator, tap, 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 you used to do. In the class also I've seen, when faculty is not giving the break, student used to drop the calculator. I've seen such kind of people. They'll be like, drop the calculator, drop the book, push your friend, so that faculty gets up and he will give the break or something. So in my class I've seen calculator tops down, a calculator goes down, books will go down, sometimes people also go down, people also fall. I take it positively that people are falling for my teaching. Anyway, just kidding. So the point is, don't take your frustration out on calculator, because if you take your frustration out on calculator, you know when the calculator will take the revenge. Not now, in the examination. Imagine in the exam hall, you're in maths class or maths exam or accounts exam, calculator is not functioning. You think your friends will help you? Nobody will help you. So there you'll be in deep trouble if calculator don't function. So take care of it, protect it. Yeah, it will be like wife when Kelsey speaks, we listen and only listen and try to understand. But don't carry multiple wives. In the sense, you can carry multiple calculator to examination. Yes, definitely. You can make a joke on wife now after getting married. Now, if you make a joke, you become a joke. in the hands of her. Anyway, so this is how M plus, M minus, MRC, GT all can be used to get the answer faster. So now we will apply this concept in the next problem, where frequency is also given. What is the standard deviation from the following data relating to the age distribution of 200 persons? Age, number of people. So when we have number of people, we have frequency. So what is the formula? We have two formula. We can use one of them. One, x bar. What is the standard deviation formula? What we learned? Summation x minus x bar, the whole square, divided by n. And whenever frequency comes, you make it capital N, sum of all those observations, and everywhere you multiply it by f. Not only in this formula, every formula, general rule, whenever frequency comes, just multiply it by f. And of course, take a square root. But this is slightly longer method because we need to know a lot of columns. We use the shortcut method, what we did now. What is that formula we require? Standard deviation is this previous formula. This formula we apply. Summation x square by n minus summation x by n whole square. Only thing is we have to multiply it by f. Wherever x is there, replace it by f. So summation x square was there, make it as fx square divided by n, minus summation x was there, make it as summation fx divided by n whole square, square root. Okay, so what are the columns required? One column we require for x, which is nothing but age. I will do one value, you please do the other values. Then we need f, that is nothing but number of people. Then we need f into x, fx. Then I need fx square, so I'm going to have one more column for x square, and then I'll do fx square. One value I compute, others you compute. Age 20, frequency 13, so 20 into 13 becomes 260. Then x square, 20 square, that becomes 400. Fx square means what? X square multiplied by f. So 400 into 13. That gives you 5,200. 5,200. Like this, you please compute for all the values and tell me what is the total you get. I hope you got it. 20, 30 given. 20 into 13 is 260. 20 square is 400. And 400 into 13 gives you 5,200. I'll do one more for you. 30 and 28. When I multiply, you get 840, 30 square, 900, 900 into 28. That is 25,200. Please do the total. Let's see how much you get. Instead of GT, if you use MRC, we get the same answer. Yes, that's, I told you both. You can do it in both the ways. But you should press M plus every time. Then you get the same answer. Okay, so let's see what total you got. Fx square 5,76,100. Fx total 10,190. 200 is the number of people. Summation F. Let's substitute. 5,76,100 and 10,190 is Fx. Number of students is 200. And you can simplify like this, or the method I told you. Using that also you can do 5,76,100 divided by 200 equals to M plus 10,190 divided by 200 into equals M minus MRC square root into equals M minus MRC square root. You get the answer. Hope you are getting that. 16.87. Let me know if any one amounts has to be calculated. Okay. Now one small question. If you are done, I'll ask you that. Just give me 1 second. Okay. Now, without preparing this table, can you get this number? Let's say 10,190, can you get it? Without preparing this table, 10,190, can you get it? Let's get it together once. Easy one. Still get it. How do you do? 20 into 13 equal to M plus. Let's do together. You can do with GT also. Let's do together. 20 into 13 equal to M plus. 30 into 28 equal to M plus. 40 into 31 equal to M plus. 50 into 46 equal to M plus. 60 into 39 equal to M plus. 70 into 23 equal to M plus. 80 into 20 equal to m plus MRC. MRC. Will you get 10,190? Are you getting it? When you press MRC, you can do with GT also. You get 10,190. So without this table, this number we can do it. Good. 200 people anyway they have given. So this also is fine. Problem is 5,76,100. Now tell me, without this table, can we get 5,76,100 in calculator? Can we get it? Do you think it's possible? Only using calculator, without using table, definitely possible. I'll tell you how. What is this? Fx square. What is fx square? F into x into x, right? So how do we do? Let's do from this. F is 13, x is 20 into 20. Let's do it together. Clear the calculator memory first. Clear. MRC 2 times. MC on everything. Let's do it together. Do it now. 13 into 20 into 20. 2 times you should do. 13 into 20 into 20 equal to m plus. 28 into 13 into 13 equal to m plus. 31 into 40 equal to m plus. 46 into 50 equal to m plus. 39 into 60 equal to m plus. 23 into 70 equal to m plus. 20 into 80 equal to m plus. MRC at last. Got it? Okay. Okay. So with this, you can do it much faster. You can save the time in exam. Let's go further. Hope you got it. Okay. Next one. If standard deviation is 16, what is the variance? Anybody? What is the answer? If standard deviation is 16, what is the variance? Answer is 4. Answer is not 4, it's 256. The reason is somehow when you look at 16, some people fix their answer. 16 means answer is 4. No, not necessarily. Standard deviation is 16. We need variance. How do you calculate variance? Variance is standard deviation square. So 16 square, 256. 16 square, 256. Okay, next. If variance is 4, what is the standard deviation? Variance is 4 means sigma square. Standard deviation can be calculated as square root of variance. Square root of 4, that is 2. Okay, next. Okay, properties of standard deviation we discussed. Change of origin but not change of scale. Okay, this one I have to explain. Combined standard deviation. Okay, this one I should explain. Give me a moment. Okay, we'll apply with the help of a problem. Let me explain this. Please pay focus. Please pay attention here. Combined mean. Remember, how do you compute combined mean? That is x bar 1, 2. How do we calculate combined mean? We used to calculate n1 x bar 1 plus n2 x bar 2. Number multiplied by the average, another number multiplied by the average, and do the total. Divided by n1 plus n2. So we knew there is a formula for combined mean like this. Like this, we also have a formula for combined standard deviation. Combined standard deviation is also very similar. First, you always convert it to variance. How do you do variance? n1 sigma 1 square. n1 number of observation you know. Sigma 1 means the variance of the first set. n1 number of observation in the first set. Sigma 1 standard deviation in the first set. Variance, sorry, standard deviation square. So variance plus n2 sigma 2 square. So it is the variance of the second set. Now it is important, plus n1 d1 square plus n2 d2 square whole divided by n1 plus n2, then take square root. So basically the question comes, what is d1, what is d2? They are the, what is d? D stands for deviations from what? Deviation from combined mean. Deviation from combined mean. Can you explain standard deviation? Which standard deviation? From the beginning, the formula, combined. So combined mean we had. Similar to combined mean, we also compute combined standard deviation. But while computing standard deviation, we don't compute standard deviation. First we compute variance, because we always go with square. So n1 observations multiplied by their variance. n2 observation multiplied by their variance. So n1 into sigma 1 square, n1 into their variance. n2 into sigma 2 square, so n2 into their variance. That is 2 parts. Then 2 more parts will come. What is the 2 more parts? n1 you know, number of observations. d1 deviation. n2 you know, number of observation. d2 again deviation. Now the question is, how do you compute the deviation? Deviation is calculated by, we had 2 sets of observations. For the 2 sets of observations, we have one combined mean. So one mean, another mean. What is the deviation? Another mean and combined mean. What is the deviation? I'll tell you this. So we have x bar 1, that is first standard deviation. We have x bar 2, that is second standard deviation. And we have one combined mean, x bar 1, 2, right? Combined standard deviation. What is the deviation between these two? That is x bar 1 minus x bar 1, 2 whole square. That is first deviation. Deviation from combined mean. This x bar 2 is x bar 2 minus x bar 1, 2 whole square. This is deviation from second mean. You understanding? d1, d2 represents deviation from overall mean, square it. So n1 multiplied by variance, n2 multiplied by variance, n1 multiplied by deviation, n2 multiplied by deviation. And how do you get the deviation? From the mean, overall mean. From the mean, overall mean. X bar 1 minus x bar 1, 2 whole square. X bar 2 minus x bar 1, 2 whole square. Mean minus combined mean. Mean minus combined mean. Are you getting it? Did you get the point? Any of this formula I should explain? I will do problem. You will understand better, but still. Got it? Okay. Now we'll apply this in the problem. You'll get a better control. One more time, tell me which number, because after explaining you can't just say once more. No, it's not singing competition. Tell me which value you could not get. I'll explain that value. Whether you could not get n1, whether you could not get sigma 1, Whether you could not get D1, D2, tell me which one, I'll explain that one. D1, D2. D1, D2 is mean minus combined mean. We have mean x bar 1, we have mean x bar 2, then combined mean. So we do x bar 1 minus x bar 1 2 whole square. Then we have x bar 2 minus x bar 1 2 whole square. From the individual mean and from the combined mean. From the individual mean to the combined mean, x bar 1, x bar 1 2. This gap is called as deviation. And here that deviation is squared. So x bar 1 minus x bar 1 2. Individual mean minus combined mean. Individual mean minus combined mean. Square it. We need deviation. Did you get the one? Deviation D1, D2. And sigma is nothing but variance. Variance of the first set of observations and variance of the second set of observations. That will be given in the problem. For N1 set, you will have one set of observations. For N2 set, you will have one more set of observations. That is what sigma 1, sigma 2, respective set of observations. Okay? Okay. 44th I know we'll have to do. First we'll do this, then I'll do 44th. First let us do this problem. Okay. If two sample size 30 and 20, what is 30 and 20? Now let's read the problem, then we'll identify. If the two sample size 30 and 20 have means 55 and 60 and variance as 16, 25 respectively, then what would be the standard deviation of the combined sample of the size 50? Okay. Now tell me, what is 30 and 20? What is 30? What is 20? How do we say? This is N1 and N2 is 20. 30 is N1, 20 is N2. Have means as 55. What is means then? 55 is x bar 1 and 60 is x bar 2. Correct? Means x bar. So x bar 1, x bar 2. Variances are 16, 25. So what is 16? Can I say sigma 1 square? Because variance only given. Variance means square. No, they have not given standard deviation. They have given variance. Variance means already square is done. And this 25 means sigma 2 square. Now before I go to the formula, any doubt in these notations? Please tell me. N1 is 30, N2 is 20, x bar 1 is 55, x bar 2 is 60, sigma 1 square is 16, sigma 2 square is 25. This much is clear? Very good. Now first you compute combined mean. How do you compute combined mean? X bar 1 2, N1 x1. So 30 multiplied by 55 plus N2 x bar 2, 20 multiplied by 60. N1 x bar 1 multiplied by then plus N2 x bar 2. Number of observations multiplied by the average. Whole divided by the total size N1 plus N2, 30 plus 20. Please compute this and tell me how much you get. $57? Okay. You get 57. Remember, we needed deviation. How do we compute deviation? D1 is calculated by x bar 1 minus x bar 1 2 square. Which is, what is x bar 1? 55. This is what is 55. Minus 57 square. That becomes 2 square, which is 4. Illustration 44, I said I will cover after this. I said illustration 44 will be covered after this. So when I go to 44, please don't ask me, sir, explain 45. That is our problem, I think. When we do one problem, you think about another problem. Hold on, we will do every problem, we will be covered. Okay, let me do D2. D2 equals x bar 2 minus x bar 1 2 whole square. Therefore, this is x bar 2, second mean, that was 60, minus 57 whole square, this is 9. Okay, now let's use the formula now. Combined mean, combined standard deviation, combined standard deviation. Square root I'll put afterwards. First I'll do this. What is required? N1. What is N1 here? 30 multiplied by 30 multiplied by sigma 1 square. What is sigma 1 here? Given, identified. Sigma 1 identified 16. 30 into 16. I'll put the brackets, plus. Second, N2, number observation 20 into sigma 2, right? Sigma 2, second standard deviation. Second standard deviation is 25. 20 into 25. Okay, plus. What else next? N1. N1, that is again 30. Into D1 square. How much is D1 square? We calculated 4 plus N2. N2 is 20 into D2 square. D2 square is 9. Whole divided by N1 plus N2, 30 plus 20, and then you can put the square root. So how much is the combined standard deviation? Comes to 5.0596. I'll round it off, 5.06. 5.06. Please do it slowly. Let me know if any of the numbers need to be explained. 5.06. We get 5.06. .42. I don't know how you got 4.42. You can use calculator to do faster. 30 into 16 equal to m plus, 20 into 25 equal to m plus, 30 into 4 equal to m plus, 20 into 9 equal to m plus, MRC divided by 50 equal to square root. D1 is not D1 square. D1 was 2. D1 square is 4. In the formula we use D1 square. So D1 was 2, but we require D1 square. So 2 square we did, and D2 was 3. 3 square we did 9. N is number of observations, correct. So we did 30, 20, 30, 20, 30, 20. That is N1, N2, number of observations. Thirty, 20, 30, 20. So they're all number of observations. Sample size. Sample size 50 only, no. One set of observation is 30. Another set of observation is 20. So one set 30, other set 20, we are combining. One sample size 30, other sample size 20, we are combining it. That's all. N1 plus N2. That is the total sample size. N1 plus N2. Done? Okay. Let's move further. Okay. This is a simple one, but still there is a logic. I'll tell you why. Compute the standard deviation of 9582. I know illustration 44 is done. Don't jump to the conclusion. I will do it. This is my material. I make sure that I cover it. Please compute standard deviation. You can use the formula. X is given by 95862. Let's do x square. 9 square 81. 5 square 25. 8 square 64. 6 square 36. 2 square 4. Total, how much you get? I think this is 30. And what is summation x square total? 210. And what is the standard deviation formula I told? Summation x square by n minus summation x by n the whole square root. Summation x square 210. Number of observations 1, 2, 3, 4, 5. 5 minus summation x 30 divided by 5 whole square root. I told you how to compute fast using the calculator. 210 divided by 5 equal to m plus 30 divided by 5 into equals m minus mrc square root. How much you get? 2.45. 2.44, I think. Whatever. 2.44. 2.449. Okay. 2.449, 2.45. Okay, so 2.449, 2.45. Hope everybody got it. Hope everybody got it. Shall I go further? Yes. Okay. 47. Please compute standard deviation for this quickly. 19, 15, 18, 16, 12. How much you get? Summation x square by n please simplify. How much you get? Standard deviation summation x square 1310 divided by number of observations 5 minus summation x 80 Divide by 5 whole square, square root. How much you get? Please do the calculator, things fast. If you can do in the calculator fast, you get the answer fast. If you do it slowly, you get slowly. You get same 2.449, same 2.449, 2.45, 2.45. This is interesting. How come your answer is not changing? How come your answer is not changing? What was the previous number values? Please observe. It was 9, 5, 8, 6, 2. Now what become? It was 9, 5, 8, 6, 2. It became now 19, 15, 18, 16, 12. You see, each value is increased by 10 each. Each value is increased by 10 each. When each value is increased, it's called as change of origin. And measures of dispersions are independent of origin. Means origin may change, but standard deviations, mean deviations, quartile deviations, range don't change. So if you apply the concept, you could have done directly. Using the calculator, you can get the quickest. But using your brain, you can do even more faster. That is where conceptual clarity must be clear. Okay, let's do one more. This one, any idea? 90, 50, 80, 60, 20. How these numbers are changed? It was 9, 5, 8, 6, 2. It is 90, 50, 80, 60, 20. That means all observations are multiplied by 10. What do you mean by all observations are multiplied by 10? It is change of scale. Change of scale. And what is the nature of standard deviation? Is it independent or dependent? Standard deviation is dependent. That means number changes. So 2.449 we had got. Now you multiply it by 10. It will become 24.49. You can compute for this. You can get the answer. But conceptually also directly you can get the answer. Both ways. You can use this summation x square method formula. You get still get the same answer, 24.49. This method also you can try. You get 24.49. Got it? Okay. Good. Now let's go to the problem. 44th, which you are not done. If standard deviation of x is 3, what is variance of 5 minus 2x? Let's say it's y. If standard deviation of x equal to 3, what is variance of y? Not sigma y. They're asking variance of y. Variance means sigma square, standard deviation square. And what is y equals? 5 minus 2x. We need square, okay, remember. Okay, now standard deviation of x is 3. Let's compute standard deviation of y. How do we do? Standard deviation of y is calculated by y equals 5 minus 2x. Tell me, what is the property I have to apply when I compute standard deviation of y? What should I do with respect to 5? Constant, ignored. Standard deviation independent of origin, which means when they give you equation, the constant should be ignored. So you have minus 2 into x. Standard deviation of x is 3. So you get it as minus 6. But it is minus 6. But what number we should take? I cannot select minus 6. What should I take? I should make it as plus 6. Why? Standard deviation cannot be negative. It's a square root. It cannot be negative. They require variance. So sigma y square is 6 square, which is 36. Which is 36. One more method also you can do. Please do this now. Sigma x is 3. What is sigma x square? 3 square becomes 9. I'll just use one more method here. Sigma x square becomes 9. Becomes 9. Now using this method, can we calculate this number directly? It is possible. You know what should you do? 5 minus 2x. 2 as usual constant is ignored. Please be careful here. Please pay attention here. Please pay attention here. When you are finding the variance, what should you do? Constant as usual should be ignored. Please pay attention here. Please pay attention here. The coefficient must be squared. Coefficient must be squared. Why? Because this is variance. Variance means it's a square, right? Therefore 2 square becomes 4 and variance of x is 9. Then also you get 36. I repeat the explanation once more. When you are calculating variance using an equation, the constant as usual ignored, but importantly the coefficient is there. That coefficient should be squared. The coefficient should be squared because variance means it's always a square. The coefficient should be squared. So here the coefficient is 2. 2 square becomes 4. As usual, substitute x by 9. So 4 into 9 becomes 36. Please write down both of these methods and let me know if you have any doubt. Got it? Important property of variance. When you're computing a variance using an equation, the coefficient should be squared. Coefficient should be squared. That's a shortcut. You can do this long method also, but shortcut is that. Okay? Clear? Let's go further. A student computes. One more question I'm getting. Minus 2 negative sign is ignored. Yes, ignored. And when you square it in variance, anyway that minus sign will be taken out. So you don't have to worry about it. In variance, when you square it, the minus sign anyway will be taken out. So you don't have to worry about the plus or minus sign. When you square it, minus is taken out. A student computes AM and SD for a set of 100 observations as 50 and 5 respectively. Later on, she discovers that she made a mistake by taking one observation as 60 instead of 50. What would be the correct mean and standard deviation if the wrong observation is left out? So what is happening here? Arithmetic mean is calculated. Arithmetic mean is calculated. Standard deviation also calculated. Arithmetic mean is calculated. Standard deviation also calculated. But there was small mistake happened. What was the mistake? They were supposed to take 50. Instead of that, they have taken 60. A small mistake happened. One second. Okay, so mistake is, it was supposed to be 50, but it was considered as 60. Now tell me, read this sentence again and tell me, what would be the correct mean if the wrong observation is left out? That means a wrong number is 60. Did we just exclude 60? Or 60 we excluded and we substituted by 50? Which one happened? I repeat the question. When they say what would be the correct mean and standard deviation if the wrong observation is left out, so did they mean wrong observation is just left out, taken out, or the right observation is also substituted? It is not substituted. Please read. Wrong observation is left out. That means wrong number is taken out. Right number is not added. Please focus on this word. Did you get it? It's not substituted. You have taken one wrong number, and that wrong number, if I throw it away, what is the answer? Does not mean right number is substituted. It is just means the wrong one is put it out. They did not say wrong number is put it out and wrong observation is observed, is substituted. They have not told. They just said wrong observation is left out. That is removed. Does not mean right one is added. Are you clear about this? Because many people make mistake here. Yes, perfect answer. Then in the new observation, there is 99 observations. In the 100 observations, I take out the one, remaining will be 99 now. For this question, if they have given the question, what would be standard deviation if wrong number is replaced, then all of your answers are right. That means wrong one, 60 is taken out and 50 is put in. Hope you are very clear here. Here, just the wrong number is taken out. Wrong number, that is 60 is removed, is taken out, is left out. This is left out. Okay, so let's compute the revised number now. But before we go to revised number, I want existing numbers. Please pay attention. I am computing existing. Okay, how did we calculate x bar then? X bar is calculated by summation x divided by n. Okay, formula you know. What is summation x? We don't know. X bar, AM is 50, standard deviation is 5, number of observation is 100. So x bar 50 equals summation x divided by n. N is 100. Remember, I am writing 100 here because this is existing number. I am yet to leave out. Okay. So summation x equals 50 into 100. It becomes 5000. This is existing. I am yet to remove. I am yet to remove the wrong number. Similarly, standard deviation. What is standard deviation? That is second formula we used to do. Standard deviation, let me write the formula. Standard deviation, okay, you know the formula. Standard deviation is 5 equals square root of summation x square by n. Can you tell me how much n I am taking now? How much n will I take? 100 or 99? 100 only. 100 only. I am still in 5. I'm not rectified. I'm calculating existing numbers. I'm yet to go for revised one. Many people do this mistake. Okay? Minus summation x by n, which is nothing but summation x, we got it. 5000 divided by 100 whole square. I'm still calculating existing one. Mind it. Now, how do I take square root in mathematics? I'll square both sides. On squaring both sides, this square and square root gets cancelled. 5 square becomes 25. This is summation x square by 100 minus 5000 by 100 is 50. 50 square means 2500. 2500. So how much do I get? Cross multiply. Okay, 2500 comes to left side. That becomes plus. So I'll write it here. 25 plus 2500 equals summation x square by 100. So it is 2525 equals summation x square by 100, or summation x square. Please cross multiply and tell me how much you get. Summation x square 2525 into 100. Okay, 252,500. Summation x square you get 252,500. 252,500. And remember, n we had taken 100. N we had taken 100. Now, what is the new one? Revised number. Revised one. Okay, revised one. You can't hear me? Is it the case with others? Is voice a problem? Okay, others are able to hear? Good. So revised number here, please observe what will happen to n. What will happen to n? Can you please tell me? Number observation now will become 99 because 1 we are leaving out. 1 we are leaving out. So 100 minus 1 becomes 99. What will happen to this 5000? From this 5000, summation x will be, I have to remove what number? Wrong one. What is the wrong number? Minus 60. 60. 50 is the right number. Read the English carefully. 50 is the right one. Right one is not considered. Wrong one is considered. Wrong one is 60. Observation as 60. Wrong one 60. That 60 is to be eliminated. Minus 60. Don't add the new one. We are not replacing. So this is 4940. Correct? 4940. Now, summation x square. I can't subtract 60 here. I cannot subtract 60 because how this number is obtained? By squaring each number. Therefore, I should do minus 60 square. So it will be 2,52,500 minus 60 square means 3,600. So what is the revised number comes to? Please tell me. 2,48,900. Okay. 2,48,900. Now let's calculate revised mean. What is x bar is 4940 divided by 99. So how much you get? 4940 divided by 99. 49.89. Okay. Is the number correct? 49.89. Then revised mean standard deviation is calculated by all new numbers. Summation x square 2,48,900 divided by 99 minus new number summation x 4940 divided by 99 whole square root. Hope you know how to calculate directly in calculator. 2,48,900 divided by 99 equal to m plus 4940 divided by 99 into equals m minus mrc square root. Into equals m minus mrc square root. How much you get? You get 4.92. Is it the case? 926. Huh? Okay, 4.93. 4.93. Hope everybody getting same numbers. 4.923. Which number you're getting? Okay, 4.92. 4.92. 4.92. 4.92. 4.92. Correct? 4.92. Is it done? Hope everybody got the same number. Yes? Everybody? Okay. Next. Okay. Next. Next one. What is that question? Please observe. What is happening here? Please read the next one. 50th. Wrong observation is replaced. Wrong observation is replaced. So here what we are going to do? Can you tell me what you are telling? That right number is added. Right number is added, substituted, replaced, added back. Right number is considered. So let me just go to the same calculation. So what will happen in the revised number now? Only the revised number I'll change it. Revised number only I'll change it. Okay. So revised number will be, n will be how much? N is 100 minus 1 plus 1. Wrong number took it out, right number put it back. So it becomes 100. What is the summation x becomes? 5000 minus the wrong number, which is 60, plus the right number, which is 50. So how much is the revised summation x comes to? My 4990. Similarly, summation x square, it is 2,52,500 minus the wrong number, minus 60 square. Remember, these are squares, plus 50 square. So here you get 2,52,500 minus 3,600 plus 50 squares, 2,500. Don't add only 50. 50 square. All these numbers are square. 2,52,500 minus 3,600 plus 2,500. How much you get? 2,51,400. 2,51,400. Okay. So revised numbers now. Revised mean x bar equals 4940 divided by 100, that is 49.4. Revised standard deviation. 2,51,400 divided by 100 minus this 4990 is it? Oh, 4990, sorry, 4990 by 100, so 49.90, 49.90. So 4990 divided by 100 square. What is the revised number comes to? You get 4.89, is it? 4.90, 4.89, okay. 4.89 or 4.90, okay. 4.90. $4.8979, let's say 4.90. So revised number is 4.90. 4.90, yes. Okay, hope it is done. Everybody got it? The revised ones. I'll go further. Coefficient of variation we already discussed. Let's do the problem. Following are the marks of 10 students. Find the coefficient of variation. Coefficient of variation. This formula, mean by standard deviation by mean into 100, this we already computed. Today only we computed in the earlier problems. Can you tell me how much we got? X bar and standard deviation, we already got it. Same problem, we already got it actually. Illustration was 40, I think. Illustration 40. From illustration 40. X bar is 56.8 and standard deviation is 13.66 or something. Yes. So coefficient of variation is 13.66 divided by 56.8 divided by 56.8 into 100. So how much you get? Some 24% approximately. 24.05%. Now we cannot comment whether it is high or less. I can only compare with another data and then I can say whether it is variation is high or more, consistency is less or more. But in general, lower the COV, higher the consistency. Okay, COV also means COVID-19. Okay, that is the right time we are looking at COV. Many are there. Your CV also will come in future. It's called as curriculum vitae. In future, that CV is important. And your life, what you do in your job is only 2 letters in computers. One is called as Control C, other is called as Control V. We do copy paste. That's all is our life in all jobs mostly. So CV comes there also. Okay, so this is the set of concepts in measures of central tendency and dispersion. This I would say is one of the highest weighted chapters from exam point of view. That's why we did so many problems and we're yet to take up practice problems that with multiple choice. These are all the concept oriented problems. So in the examination, maybe you can even expect some exam, it has come 10 marks also. Around 7 to 8 marks you can definitely expect. Definitely you can expect around 7 to 8 marks from this chapter. 7 to 8 marks you can say. 7 marks, 8 marks you can expect. In one exam it came 10 marks also. But 7 to 8, 6, 7, 8 is average. So this will be double the previous chapter. So the statistical description of data, that was 3 to 4 marks. The double of this is this chapter, one of the high weighted chapter. Along with probability, this has got the highest chapters. Weightage of all chapters, as and when we discuss, we'll come to it. 25% of total. No, I don't say 25% of, okay, 25% of that, okay, one exam only it happened. Otherwise, you say around, you can say that around 20% you can say. Yeah, let's say 20%, this 20% of the total is from this. And probability is another. So this chapter and probability will almost carry about, I can say 15 marks. This chapter along with probability will carry about 15 marks in exam. So these two chapters are high weighted. Rest are all equal. Rest of the chapters are equal. Only the chapter heavy weights are these two. One is probability and the another is this measures of dispersion. Central tendency and dispersion, both are together. Put together, tendency and dispersion and probability. Maybe along with these two chapters you can think about passing the exam also. This is that much of heavy weights, these two chapters put together. Okay, so on this we have to solve practice problems that we will take it up tomorrow. So we'll stop at this point. Have a nice time. Have a nice day. We'll see you tomorrow at same time, 2:30. Till then, have a nice time. Happy learning. See you. Bye-bye.